Hello 4A class. I just wanted to go over the test that we just took right here. First of all, I just wanted to give you the scores right here. 26 people got at least 88%, which is the A range if you have all the homework and lab points right there. 28 people got at least in the range from 63% to 88%. We said that was the B range. And 17 people got in the range from 43% to 63% right here, and that was the C range. Just remember that I'm assuming you have all the homework and lab points right there. So there's just how the scores went. 23 people got below that 43%. This is about what I would normally get even without a coronavirus right here. So, okay, so I can't go over all the tests. There were 6 tests. And so I'm just going to pick selected questions, one from each section. They were all fairly similar right here. So this first one right here was, we had just 2 vectors. One of magnitude 70, which was our B at 30 degrees, and we had another one that had a magnitude of 70 square root of 3 at 60 degrees. Yours might have been slightly different, but it was the way you work it out would be exactly the same. So I said, first of all, write A in terms of I and J. Well, A would be 70 square root of 3 times the cosine of 60 in the I, and 70 square root of 3 sine 60 in the J. So that just gives me this right here, 35 square root of 3 plus 105. The B, this is negative, it'd be negative 70 cosine 30 minus 70 sine 30. So there's what we get for B. On this one, I asked, what was the magnitude of A minus B? So I first need to find A minus B. So I just subtract these two. This minus that would double it because you're subtracting a negative. 105 minus a minus 35. Sorry, 105 minus a minus 35 would be 140 right there. And so the magnitude would just be the square root of the first term squared plus the second term squared. And you notice if I pulled a 70 out of both of these two, you'd be left with 3 there, and that would be 2 squared, which is 4. 3 and 4 is 7. So it's 70 square root of 7. I also asked the tangent of the angle between A minus B. Well, first of all, where was A minus B? There is B. Minus B was exactly on the opposite side, and so we really just had to add these two together. A and minus B would be this green vector all the way out to there. And this length right there would correspond to 70 square root of 3, and this height right there would correspond to 140. So if I wanted to find this angle, the tangent of that angle is just the y over the x. So it's just the 140, the y over the 70 square root of 3. Cancel out a 70, 2 over the square root of 3. We want to also ask for the dot product. The dot product of A dot B should not have any i's and j's. It's just this number times this, 35 square root of 3 times minus 35 square root of 3, plus 105 times minus 35. Plug all that in, you get minus 7,350. Okay, then I asked you to find A cross K, quantity, cross A. So we'll first do the A cross K. Well, here is my matrix. Here's my A. There's my K. Copy it down. And when we go down this way, we got 105 i's, and we got minus 35 square root of 3j. So there is A cross K. Now we want to take this and cross it with A again. So there's my A cross K. There's my A. And so if we come down this way, right here, the only one that survives is this last term right here, which is the 105 squared. And then when we subtract off the other one, it's this one right here. And they're both in the K right here. So we subtract these two and we get 14,700 in the K right there. So there's that first one. The second problem right here, this is the one where we had Stan and Kathy heading towards each other right here. Here, Kathy was accelerating at A and Stan was accelerating this way at 6/5 A right here. So first of all, we wanted to list all the parameters for Stan and Kathy. Well, and I said this is my origin right here. So Stan starts at big D, and I called this little d because we want to calculate the distance Stan moves. We said it was little d. So the final position of both of them are this, which is big D minus little d. They both started from rest. They both have a final speed, and the acceleration of Stan was negative right here. Okay, so we just said, let's just plug in the constant acceleration, plug in this equation to both Stan and Kathy right here. Here's Stan's, here's Kathy. Set them equal to each other. If we set these two equal to each other, then I can throw this on the other side, and we get D is just the sum of these two. Combine these two, solve for T. So there's your T. There's the time it takes. Once we have the time, we can go back and plug it into either one of these two formulas. I'm going to plug it into the top one because the big D's cancel and the minuses cancel. So big D is just 11/10 AT, little d is 3/5 A times the time squared right here, and it's 6/11. Some of you on the test solve for the wrong distance right here. Just go back and look at your test to find out which one you solved for. Now, if we wanted to get the velocity of Kathy, it was just AT, V naught plus AT, V naught was 0. So it's just A times the time, which just brings the A in the numerator. And the velocity of Stan would just be his A times T, except I did say his speed. I didn't take off if you didn't, but his speed is always a positive number right here, so you could get rid of the minus sign right there. Okay, I also asked how much time would it take for them to meet if Kathy accelerated the other way instead? Well, all we have to do is come back to here and call that minus A right here. That's the only difference. So really, it just meant that was a minus A, which just meant that was a minus right there. That's the only difference. So now we're subtracting these two. 3/5 minus 1/2 is 1/10. Multiply the 10 over and divide by the A and take the square root. There's the time right there. So that was the Stan-Kathy problem. We also had down here, we had a problem whether it could have been a drone, a balloon, an elevator, they're all the same problem, but you had an object going up and back down again. They were all the same. The only thing that differed was what was given. Sometimes I gave you V naught and 8, sometimes I gave you the final speed and time. This was the only thing that changed out of all the different tests right here. So I'm just going to pick this one right here. I'm going to call this distance little h and that distance big H. So if we list everything between A and C on that red coordinate system, x sub naught is 0, the final x is negative h, v naught is 0, the final speed is vc, a is minus g, time is tac. If I gave you the final speed and I used this coordinate system, you needed to put a minus in for final velocity because it would have been negative if it was given right here. If we go between A and B, now we're just going between these 2 points. X sub naught is 0, final x is big H, v naught is v naught, the speed up here is 0, and the time is TAB. So first of all, I think what we wanted to get was the final speed on this test right here. Since I'm giving you the initial speed and the height, then we'll use this equation because this uses all that information. So we can say VC squared, which is what we wanted, is V naught squared, which is given, plus 2A, which is given, minus G, minus H minus 0. And so we get this right here. So VC is plus or minus the square root of V naught squared plus 2GH. We want the minus in here because it's going downward right here. If you put the plus in there, you're going to get, when you carry that on, you're going to get incorrect answers. Okay, so now if we wanted to also calculate the time it takes to go from A to C, well, you could have used the x equal x sub naught equation, but I'm just going to use the V equals V naught plus AT. Well, I know Now if I just solve for gt, that's what I want. Bring that over here and bring the vc back right here. Now I can just divide out the g, and it's v naught minus vc. Well, since that's a minus, this becomes a plus. And so it's the square root of v naught squared plus 2gh. You can see right here, remember the time from here to here would have been v naught over g, and then the time down the other side would have been this. They both should be positive right there. Okay, and now we also wanted to find the total height right here. Well, since we're given little h, all I have to do is solve for big H and add little h to it. So between A and B, we'll plug in, use the fact that V is 0 at the highest point, and we get 0 equals V naught squared plus 2 minus GH. So this is what we get for big H. So the total height would be big H plus little h, which is little h plus V naught squared over 2g. I also asked you for the acceleration at the highest point. We know it's g and it's downward right here. I don't know why you had to solve for it. It's given right here. Okay, over here we had a two-dimensional problem. Here we were throwing something out at 60 degrees and we were looking at it between here and then when it gets to its highest point right here. Some of them were exactly like this but in reverse right here. But here we're just running it in this direction right here. So I put my origin right there. List x sub naught is 0, y naught 0. Here x is r, y is h. The x component would be v naught cosine 60, v naught sine 60. These two are the same. Vy is 0 up here. Ax is 0, ay is minus g. And so on this one right here, you were given the time. So if we're given the time, if we plug into this equation right here, Vy is 0, V naught y is square root of 3 over 2, V naught minus gt, we can solve for the time. Throw this on the other side, and we want to solve for V naught. Yep, throw the gt on the other side, multiply by 2 over the square root of 3. So there's your V naught. We also wanted to get this distance r. We can use our x equal x sub naught equation. X, which is r, x sub naught is 0. You get v naught x, which is 1/2 v naught t plus 0. So we just take our v naught from right there, plug it right in here, and so there's my r. Over here, we also wanted to find the height right here. We'll plug in this equation. We could have used another one, but we'll just plug in this. We know Vy is 0. We know V naught y squared. V naught y is this. It's 3/4 V naught squared plus 2 times minus g, so that's minus 2gh. So we can solve for h. 3 V naught squared over 8g, and then plug in your V naught squared. Take that squared, plug it in there, and we get 1/2 gt squared. And then I also wanted to calculate what was the speed at the highest point. Well, the speed at the highest point, well, right there, it has no y. It's just 1/2 v naught. So it's just half of this. Half of that, just get rid of the 2. It's just 1 over the square root of 3 gt. Okay, now the extra credit problem, since I don't have enough space in here, I'm just going to show you how you would set it up. Here we have the car accelerating. Then it went at constant speed for triple the time, and then it deaccelerated at a over 3 until it stopped. So here was our list between A and B: 0, D1, V naught is 0, VB, A is A, T is T. Now, most of the people that got this wrong is because they said that x sub naught is D1 and x is D2. It's not. Way out there, this point is D1, this point is D1 plus D2. This is D1 plus D2 plus D3. So make sure you put those in there. V naught is VB, and since A is 0, the final speed is VB, and the time was 3t. So we could use the x equal x sub naught to get the distance, D1. We could use the v equals v naught to get VB. Now you got those two. Over here, we could use the x equal x sub naught, and we could get D2. And then over here, we don't want to use the time equation because you weren't given that time. use the one that doesn't have the time, which is the v squared equals v naught squared. And you can calculate d3 from this one. So d3 you get from there, d2, d1, add the 3 up, and that's what will give you the answer right here. And they're all going to be the same, just different numbers in there. Okay, hopefully that you understand this test.